It's not uncommon for examiners to give us sets in Venn diagrams, and they want us to shade particular region or regions that indicate certain subsets or addition of two or more sets. So what we quickly do is, for example, here we have that A, B, and C are subset of a universal set, and we have to indicate by shading the region shown by A union B. A union B. So the first one is that you have set A, you have set B. This is A and this is B. And this is our universal set covering everything. So we can see both A and B, they are inside the universal set. And they said A union B. A union B means all elements of A plus all elements of B, as what we had in our previous example under sets. So I want to enjoin those who have not watched this video to quickly go there and check. So A union B means addition of A and B and their overlap, that's their intersection. But the intersection, you won't repeat it twice, just write it once. So this means we consider all A's alone without overlapping. Those that appear both in A and B just once, write it once. So, and those that appear in B alone. So this is the shading for A union B. A union B, which is this first one. So we move on to the second one, A intersection B. To shade for A intersection B, so we are still on this. That's number 2. To shade for A intersection B. A intersection B simply means what is common to A and B. The elements that appear in A and they also appear in B. They are elements common to A and B. And if you check this diagram, it is this portion that the two circles overlap each other. So we have, this is simply A intersection B. We move on to number 3. Number 3 is asking us to find number 3 is asking that we obtain value for A complement intersection B complement. So like we said the other time, A complement is same thing as A prime. B complement is same thing as B prime. A complement means those elements present in the universal set but are not in A. In other words, not A. That is the meaning of A complement, not A. So those that are not A, they are outside the circle of this A. And those that are not B, they are outside the circle of this B. And those that are outside the circle of A and are outside the circle of B simultaneously. So the two of them, because those outside A, let me change the color. The complement of A are those that are outside A. Those that are outside A. Do you know that this one is parts? It is outside A. Okay, that is for A alone. Then they also talk those that are outside B. I want to use another color. Those that are outside B here are this. So outside B, including those that are here, they are outside B. Now, if you check the two shaded together, where do you think they converge? both the blue shading and the red shading, you see that they don't converge here, they don't converge here. Both of them converge outside here. So meaning that the shading will simply be outside alone, outside. So that is A complement intersection B complement, which is the same thing as by De Morgan's law. A complement intersection B complement is the same thing as A union B, everything complements. Just like if you have A prime union B prime. Another way of interpreting this is to say A intersection B, then you say O prime, according to De Morgan's law in sets. So for this one, this is what we have for A union B. This is the whole of this white one is A union B. Since it is complement opposite, the not A union B, we leave A union B, then we shade every other place. That is the same value for A complement intersection B complement. So we go to number 4. Number 4, if you look at what we have there, in this number 4, we are asked to find A complement union B. A complement already means B means the whole of this circle. We want to add it to A complement. That is, we want to add it to values outside circle A. So A complement union B means adding this B to the complement of A. Already this B, this part of B, where we have B only, is already complement, is already part of complement of A. So these are the complement of A outside A. We are asked to add it with B, meaning that apart from A itself, meaning that apart from A, every other thing, including B, apart from A, every other thing, including B. So, and that is what we have. There's only A that will be excluded. Elsewhere will be shaded, including this portion of B. So that is A complement union B. A complement union B, meaning that you shade the part of B not intersect with A because A is completely complement. It's already not shaded. Then, and other parts outside A, every part outside A will be shaded for this A complement. So that is what we have there. And lastly, we check number 5. Number 5, we have A complement intersection B. A complement intersection B. If you talk about A complements, complement of A are elsewhere apart from this circle for A. Those elsewhere where it intersects with B. Those elsewhere where it intersect with B. Let me use, this is already A complement all this one with blue. It's blue. And if they now ask that A complement intersection with B, you know B already is this one, is the whole of this circle. So where the complements of A and B, where they intersect, is within this region. So that means if we want to do this, we simply say A complement intersection B is within this region now. So that is A complement intersection B. Then we move on to those with 3 subsets. Under the 3 subsets, we have A, we have B, we have another one, C. This is A, this is B, and this is C. So I want to answer number 6. Number 6 demands that we find A prime intersection B prime intersection C. This one is like only C, excluding B and A. C only, excluding B and A. So the answer to that one is shading this place. That is only C. And lastly, without wasting our time, number 7 in the last for today is we have A intersection B prime, A and B, outside this A and B, then outside A and C. So S way you shade, you add them together, meaning that we'll have this place to shade. So apart from this region, and this is the end of our lecture on the shading of Venn diagram. Do follow us by subscribing to this channel.